this video, we are going to talk about how to multiply matrices. We will also talk about the adjoint of matrices, the transpose, and also how to find inverse of both 2 by 2 and 3 by 3 matrices. So let's start with the matrix multiplication. Now, in order to multiply two matrices, matrix 1 and then matrix 2, the condition that must be both matrices must meet is that the number of columns in matrix 1 must be equal to the number of rows in matrix 2. So for example, let's assume we have this 2 by 2 matrix, which is 2 0 4 5, and then we want to multiply by this other 2 by 2 matrix, which is 3 1 1 minus 2. What will be the answer? So this is equal to, what we'll do is that you take this row, then you multiply the individual components of the row by the individual components of this column. So in this case, it's going to be 2 times 3, then plus 0 times 1. Then you use that to multiply this. So here will be 2 times 1, then plus 0 times minus 2. So bracket close. And then here is going to be 4 times 3, and then plus 5 times 1. Then you multiply by this last column. So 4 times 1, and then plus 5 times minus 2. So if we further simplify, 2 times 3 is 6, plus 0 times 1 is 0. 6 plus 0 is 6. Then 2 times 1 is 2, plus 0 times minus 2 is 0. So here is also 2. Then 4 times 3 is 12, plus 5 times 1, that's 17. So here is 17. And then 4 times 1 is 4, then plus 5 times minus 2, that's 4 minus 10, which is the same as minus 6. So this is the result of that multiplication. So let's take another example. Let's assume we are given this 3 by 2 matrix, which is 3 4, and then minus 1 2, and then 0 1. We are supposed to multiply by this 2 by 3 matrix, which is minus 1 2 1, and then 1 2 3. How do we multiply these two matrices? We must ensure that the condition of multiplication is first met, and that is, you see that this first matrix is a 3 by 2 matrix, and then this second matrix is a 2 by 3 matrix. Number of columns in the first matrix must be equal to the number of rows in the second matrix. So you can see that this one has 2 columns and this one has 2 rows. So we can multiply the two matrices. So now let's open a big bracket here. So you take the first row and multiply by the first column. So that will be 3 times minus 1, then plus 4 times 1. Then this side will be 3 times 2, then plus 4 times 2. And then this side it will be 3 times 1, then plus 4 times 3. And then let's close the bracket here. And let's take this row, minus 1 and 2. So here will be minus 1 times minus 1, then plus 2 times 1. And then this side will be minus 1 times 2, and then plus 2 times 2. Then here will be minus 1 times 1, and plus 2 times 3. Then let's take this other row, which is the 0 1. So here will be 0 times minus 1, then plus 1 times 1. And here is 0 times 2, and plus 1 times 2. And here is 0 times 1 plus 1 times 3. So let's further simplify. So this is equal to, now 3 times minus 1 is minus 3. Then 4 times 1 is 4. Minus 3 plus 4 will give us 1 here. And then here is 3 times 2 is 6, then plus 4 times 2 is 8. So 6 plus 8, that will give us 14. So here's 14. 3 times 1 is 3. Then 4 times 3 is 12. 3 plus 12 will give us 15. So here's 15. So bracket close. Then minus 1 times minus 1 will give us 1. Plus 2 times 1, here will be 3. Then minus 1 times 2 is minus 2. Plus 2 times 2, that will be minus 2 plus 4, which is 2. Then minus 1 times 1 is minus 1. Plus 2 times 3 is 6. Minus 1 plus 6 is 5. Then 0 times minus 1 is 0. Plus 1 times 1 is 1. Then 0 times 2 is 0. Plus 1 times 2 is 2. 0 times 1 is 0. Plus 1 times 3 is 3. So we have been given this 3 by 3 matrix to multiply. So the first matrix is 2, 3, 4, 3, 4, 5, 4, 5, 6. And the second matrix is 1 minus 3, 5, 0, 2, 4, 3, 0, 5. So let's open a bigger bracket here. So this is equal to, just as we did for the previous example. So take the first row and multiply the first column. So here will give us 2 times 1 plus 3 times 0, then plus 4 times 3. Then this side will be 2 times minus 3, 3 times plus 3 times 2, then plus 4 times 0. And then this side will be 2 times 5, then plus 3 times 4, then plus 4 times 5. Then let's come and take this row and multiply this column. So here will be 3 times 1, and plus 4 times 0, and plus 5 times 3. And then we use this same row to multiply the second column. That will be 3 times minus 3, then plus 4 times 2, then plus 5 times 0. So this place will be 3 times 5, then plus 4 times 4, then plus 5 times 5. Then here we take the last row and multiply. So here will be 4 times 1 plus 5 times 0 plus 6 times 3. Then here is 4 times minus 3 and plus 5 times 2, then plus 6 times 0. Then here is 4 times 5 plus 5 times 4, then plus 6 times 5. So if we further simplify, 2 times 2 is 2, 2 times 1 is 2, plus 3 times 0 is 0. So 2 plus 0 is 2, plus 4 times 3, that's 12. So 2 plus 12 is going to give us 14. And then at this place, and then here, you see that here is 2 times minus 3 plus 3 times 2. That's, if we add both, it will give us 0. Then plus 4 times 0 is 0. So here is 0. Then here is 2 times 5. That's 10. Then plus 3 times 4, 12. 10 plus 12 is 22. And 22 plus 4 times 5. That will give us 42. So here is 42. Then here is 3 times 1. That's 3 times 4 times plus 4 times 0. That's still 3. And plus 5 times 3. That's 15 plus 3. So here is 18. And then here is 3 times minus 3. That's minus 9. Then 4 times 2 is 8. Minus 9 plus 8 is minus 5. Sorry. Minus 9 plus 8 is minus 1. Plus 5 times 0 is still minus 1. So here's minus 1. And then here is 3 times 5 is 15. 15 plus 6, 16, then plus 5 times 5 is 25. All of that will give us 56. Then 4 times 1 is 4, plus 5 times 0 is 0. So 4 plus 0 is 4, plus 6 times 3 is 18. 4 plus 18 is 22. Then 4 times minus 3 is minus 12, plus 5 times 2 is 10. Minus 12 plus 10 is minus 2. Minus 2 plus 0 is still minus 2, so yes, minus 2. And then here's 4 times 5 is 20, plus another 5 times 4, that's 20. 20 plus 20 is 40. Then 6 times 5 is 30. 40 plus 30 is 70. Now let's talk about the determinant of a 2 by 2 matrix. So assuming we are given matrix A equals A, B, C, D, and we are asked to find the determinant of A, which is usually represented as det A, then that is equal to multiply the leading diagonal and subtract it from the multiplication of the other diagonal. So here is going to give us A times D, then minus C times B. So assuming we're given a matrix which is A equals 0, 3, 2, 1. What is the determinant of A? So the determinant of A is equal to multiply the leading diagonal, which is 0 times 1, then minus the other diagonal, which is 2 times 3. So that is going to give us 0 times 1 is 0, minus 2 times 3 is 6. So here is going to give us minus 6. Now, how do you find the inverse of a 2 by 2 matrix? So if you are given 2 by 2 matrix, A inverse is equal to 1 over the determinant of A, then times. Then what you do is that you interchange A and D so that D comes here and then A comes here. Then you multiply the other side by negatives. So here becomes minus B and then minus C. So let's take an example. Assuming A is equal to 4, 2, 3, 0. What is A inverse? So you can find A inverse by first finding the determinant of A, which is equal to 4 times 0 minus 3 times 2. And that will give us minus 6. So the A inverse is equal to 1 over minus 6. Then times. We interchange 0 and 4. So here becomes 0. And then here becomes 4. And multiply the other diagonal by my negative 1. So yes, minus 2 and then minus 3. So let's assume we have been given B. So B is equal to 2 minus 2, 6 and then 3. Find B inverse. So let's find determinant of B. That is equal to 2 times 3, then minus 6 times minus 2. And this is equal to 2 times 3 is 6, then minus 6 times minus 2 will give us plus 12. And then 6 plus 12 is equal to 18. So B inverse is equal to 1 over 18 and times interchange 2 and 3. So here becomes 3 and here becomes 2. And multiply the other diagonal by negative 1. So here becomes 2 and here becomes minus 6. A is equal to 3, 2 minus 3, 2, 2 minus 4, and minus 4, 2, 1. We are supposed to find the determinant of this matrix. So now we are supposed to find det A. Now, for every 3 by 3 matrix, it has a principle of alternating signs, which is if here is plus, here is supposed to be minus, and here is plus, and here is minus, here is plus, and here is minus, here is plus, here is minus, here is plus. So what it means is that if we take any row, then we are supposed to multiply by the corresponding sign that it's supposed to have. So now what we'll do is that, for example, if we are using the first row, now when you write the first element, then you cross out the row and the column in which the element appears. So here, if we cross out this row and we cross out this column, we'll be left with this 2 by 2 matrix, which is 2 minus 4 and then 2 1. Then in this place here will be minus 2 because there is a minus here, and we cross out the row and then the column in which the minus 2 appears. So we'll be left with this 2 by 2 matrix, which is 2 minus 4 and then minus 4 and 1. Then here is minus 3. Then we'll cross out the row and then the column. So we'll be left with this 2 by 2 matrix, which is 2 2 and then minus 4 and then 2. So now we already know how to find the determinant of a 2 by 2 matrix. So here becomes 1 times. So we multiply the leading diagonal, which is 2 times 1, then minus 2 times minus 4, and then minus 2 to bracket 2 times 1, then minus 4 times minus 4, then minus 3, 2 times 2, then minus 4 times 2. So here becomes 1 times 2 times 1 is 2, then minus 2 times minus 4 is plus 8. So 2 plus 8 is 10. Then here is minus 4 times minus 4 is 16. Now 2 minus 16 minus 14, then minus 14 times minus 2 is equal to 28. So here is plus 28. And then if we come to this side, here is 2 times minus 2, which is minus 4. Then minus 4 times 2 is minus 8. So we have minus 4 minus 8, which will give us minus 4 plus 8, and that will give us 4. So minus 3 times minus 4. Sorry, I made a mistake here. So here is supposed to be 2. It's 2 times 2. 2 times 2 minus 4 times 2 is 12. Minus 3 times 12 is minus 36. So if we add all of this, we are going to get the determinant equal to 2. So this is equal to 2. Let's take another example. B is equal to 2 1 2 minus 3, then 1 1 0, and minus 1 4 and minus 6. What is the determinant of B? So just as we did, so plus minus plus. So you take 1, then cross out the row and column in which that element appears. So we'll be left with 1 0 4 minus 6. 1 0 4 minus 6. Then we are left with minus 2. Cross out the row and column in which minus 2 appears. So we left with 1 0 minus 1 and minus 6. 1 0 minus 1 and minus 6. Then let's take the last element, which is minus 3. Cross out the row and column in which it appears. We are left with 1 1 minus 1 and then 4. So here is 1 times minus 6, then minus 4 times 0. Then we have minus 2. 1 times minus 6. And then here is minus 1. Minus 0 times minus 1. And then here is minus 3 times 1 times 4. Then minus 1 times 1. So here is 1 times minus 6 is minus 6, and 4 times 0 is 0. So here will be 1 times minus 6. And then here is minus 2. Then we have 0 times minus 1 is 0. So 1 times minus 6 is minus 6. Then here is minus 3. We have minus 1 times 1 is minus 1. So minus 1 times minus 1 is plus 1. 1 times 4 is 4. 4 plus 1 is 5. So here is 1 times minus 6 is minus 6. And then minus 2 times minus 6 is plus 12. Then minus 3 times 15. Sorry, minus 3 times 5 is minus 15. So minus 6 plus 12 is 6. And 6 minus 15 is equal to minus 9. So the determinant of B is that B is equal to minus 9. Now let's talk about the transpose of matrices. So we are given this matrix A, which is equal to minus 1, 2, and 1, 0, 0, minus 2, and then 1, minus 5, and 4. So we are supposed to find the transpose of A. We can find the transpose of A by turning all the rows of A into columns. So A transpose is equal to, take the first row and turn it into the first column. So minus 1, 2, and 1. Take the second row and turn it into the second column. 0, 0, minus 2. And take the third row and turn it into the third column. So this becomes 1, minus 5, and then 4. So this is the transpose of A. We are also given another matrix, which is matrix B, which is equal to 1, 0, 2, 0, 1, 1, 2, 3, 0. We are supposed to find the transpose of B. So the transpose of B is equal to, take the first row and turn it into the first column. So 1, 0, 2. Take the second row, turn it into the second column. 0, 1, 1. Take the third row and turn it into the third column. 2, 3, 0. So this is the transpose of B. And then we are given this matrix, which is matrix C, equals 3 minus 2 minus 1. And then 2 minus 1 minus 1. And then 4 minus 3, 7. We are supposed to find the transpose of C. So the transpose of matrix C is equal to, take the first row, turn it into the first column. So 3 minus 2 minus 1. Take the second row, turn it into the second column. 2 minus 1 minus 1. And then take the third row, turn it into the third column. 4 minus 3, and then 7. So this is the transpose of C. Now let's talk about the inverse of 3 by 3 matrices. So if we have a matrix A, then the inverse of matrix A is giving us 1 over the determinant of matrix A, then times the adjunct of matrix A. So this is the general formula for finding the inverse of a 3 by 3 matrix. So let's assume we have a matrix A, which is giving us minus 1, 2, 1, 0, 0, minus 2, and then 1, minus 5, and 4. Now, what is the inverse of matrix A? So the first thing is that from the formula, we need to know the determinant. So let's find the determinant of A. So this is equal to, remember what we said, here is plus, minus, and then plus. So we need to bring out minus 1. Then rule out the row and column in which minus 1 exists. So we are left with 0, minus, minus 2, and then minus 4, sorry, minus 5 and 4. And the next one is 2, minus 2. Now the row and column of 2. So we'll be left with 0, minus 2, and then 1 and 4. Then the last one is plus 1. Rule out the row and column of 1. So we'll be left with 0, 0, 1, minus 5. So this is equal to minus 1. Then let's find the determinant of this 2 by 2 matrix. So it will be 0 times 4, then minus, into bracket, minus 2 times minus 5, bracket close, then minus 2. 0 times 4 then minus 1 times minus 2, then plus 1. 0 times minus 5 minus 1 times 0. So this is equal to minus 1. 0 times 4 is 0. Then minus 2 times minus 5 is 10. 10 times minus 1 is minus 10. Then here is minus 2. Minus 1 times minus 2 is 2. So here is 2. And then plus 1. 0 times minus 5 is 0. Minus 1 times 0 is 0. So here is 0. So at the end of the day, minus 1 times minus 10 is 10. 10 minus 4 is 6. So we are going to get 6 here. The next thing we will do is to find the matrix of minus. So that means that for each of the elements here, we are supposed to find the determinant of each 2 by 2 matrix. So let's put a big bracket here. So with the matrix of minus, so when we take minus 1 out, what is the 2 by 2 matrix that is left? It is determinant of 0, minus 2, and then minus 5 and 4. Then we'll come to here, 2. When we rule out 2, what is left is 0, minus 2, 1 and 4. 0, minus 2, 1 and then 4. Then we'll come to this last thing. When we rule out 1, so the row and the column of 1, we are left with 0, 0, 1 minus 5. So 0, 0, 1 minus 5. Then let's come to this element, this 0. When we rule out the row and column of this 0, we are left with 2, 1 minus 5, 4. So here is 2, 1 minus 5 and then 4. Then let's come to this 0. If we rule out the row and then the column of this 0, we are left with minus 1, 1, 1, 4. So minus 1, 1, 1 and then 4. Then let's come to this minus 2. If we rule out the row and column of this minus 2, we are left with minus 1, 2, 1 minus 5. So minus 1, 2, 1 and then minus 5. Then let's come to this one. Rule out the row and column of this one. We are left with 2, 1, 0 minus 2. 2, 1, 0 minus 2. Then when we come to this element, which is minus 5, if we rule out the row and column of minus 5, we are left with minus 1, 1, 0 minus 2. So minus 1, 1, 0 minus 2. And then the last one is this one, which is 4. If we rule out the row and column of 4, we are left with minus 1, 2, 0, 0. So minus 1, 2, 0, 0. So now the next thing is to find the determinant of each of the 2 by 2 matrices. So to find the determinant of this is 0 times 4. 0 times 4 is 0. Now minus 5 times minus 2 is 10 times minus 1. So here is minus 10. And then if we come here, 0 times 4 is 0. Now we have minus 1 times minus 2. That will be 2. Then here 0 times 0 is 0. 0 times minus 5 is 0. 0 times 1 is 0. So here is 0. And then now let's come to this one. 2 times 4 is 8. So we have 8 here. Then 8 minus, we have minus 5 times 1. So minus 5 times 1 is 5 minus 5. 8 minus 5 is 13. So here is 13. Then here is minus 1 times 4. That will give us minus 4. Then minus 1 times 1 is 1. So minus 4 minus 1 is minus 5. Then if we come to this one, minus 1 times minus 5 is 5. Then minus 1 times 2 is 2. So 5 minus 2 is 3. So here is 3. Then here is 2 times minus 2 is minus 4. Then minus 0 times 1 is 0. So here is minus 4. And then minus 1 times minus 2 is 2. Minus 0 times 1, we still get 2. and then here is minus 1 times 0 is 0, then 0 times 2 is also 0, so here is 0. So we've been able to find this is the matrix of minus. So these are the minus of A. Now the next thing we need to do is to multiply each of these minus by the corresponding signs so that we will get the matrix of cofactors. Remember we said if we start from plus, here's plus, for a 3 by 3 matrix, plus, minus, plus. The signs must alternate. Then we have minus, plus, minus, then plus, minus, plus. So we are going to multiply each of these by this. So if we take this, the minus 10 remains, but we need to multiply these two by minus 1, so it becomes minus 2, then 0. Then we need to multiply this 13 by minus 1, so here it becomes minus 13. Then the minus 5 remains. We need to multiply this 3 by minus 1, so here becomes minus 3. Then the minus 4 remains in this case. Then we need to multiply these 2 by minus 1, so here becomes minus 2, then 0. So this is called matrix of the cofactors. Then having that, now that we are done with this, we need to find the adjoint. The adjoint is, if you find the transpose of the matrix of cofactors, then that becomes the adjoint. So A inverse is equal to 1 over the determinant of A. Remember, we got determinant of A as 6, so 1 over 6, then times the adjoint of A. So we need to find the transpose of the cofactors, and that becomes the adjoint of A. Now, remember what we said. Transpose, take the first row and make it the first column. So here is minus 10, minus 2, and then 0. Take the second row, make it the second column. Minus 13, minus 5, and then minus 3. Take the third row and make it the third column. Minus 4, minus 2, and then 0. So this is our A inverse. So let's take this other example. Matrix B is given as 1, 1, 1, 3, 6, 1, 2, 3. We are supposed to find the inverse of matrix B, which is B inverse. So in finding the inverse of a 3 by 3 matrix, the first thing is to find the determinant. So let's find the determinant of B. So remember we said is plus, minus, if we are using the first row, plus, minus, plus. You can use the second row, but in that case, that will be minus, plus, minus. So here becomes 1. Then we rule out the row and column in which 1 is. So here is 3, 6, 2, 3. And then minus 1. Rule out the row and column of 1. So we are left with 1, 6, 1, 3. Then plus 1. Rule out the row and column of 1. We are left with 1, 3, 1, 2. So this becomes 1 into bracket. 3 times 3 is 9. Then minus 2 times 6 is 12. Then minus 1. 1 times 3 is 3. Then minus 1 times 6 is 6. Then plus 1. 1 times 2 is 2. Then minus 1 times 3 is 3. So this becomes 9 minus 12 is minus 3. Minus 3 times 1 is the same as minus 3. Then 3 minus 6 is minus 3 times minus 1. It becomes plus 3. Then 2 minus 3 is minus 1. Minus 1 times 1 is minus 1. So you see that this is equal to minus 1. So the determinant of B is equal to minus 1. The next thing we are supposed to do is to find the matrix of minus. So with the minus, let's construct a big column here. So take the first one, which is 1, and then rule out the row and column of 1. If we do that, we are going to be left with the matrix of 3, 6, 2, 3. Then take this one, rule out the row and column of 1. We are going to be left with 1, 6, 1, 3. Then take this last one, rule out the row and column. We are going to be left with 1, 3, 1, 2. Let's close the bracket. Then let's take this one, rule out the row and column. So if we rule out the row and column of this, we are going to leave 1, 1, 2, 3. So yes, 1, 1, 2, 3. Then let's take this 3, rule out the row and column. We are going to do 1 1 1 3. So yes, 1 1 1 3. Then let's take this 6. If we rule out the row and column, we are going to let 1 1 1 2. So yes, 1 1 1 2. Then let's take this 1. If we rule out the row and column, to be level 1 1 3 6. So here's 1 1 3 6. Then if you take these 2, if you rule out the row and then the column, we are going to be left with 1 1 1 1 1 6. So here's 1 1 1 6. Then if we take this 3 and rule out the row and column, we are going to let 1 1 1 3. So yes, 1 1 1 3. The next thing is we are supposed to find the determinant of each of the 2 by 2 matrix. So yes, 3 times 3 is 9. So 9 minus 12, 2 times 6, which is 12. That will give us minus 3. So yes, minus 3. Then 1 times 3 is 3. Then 1 times 6 is 6. So 3 minus 6 is also minus 3. Then here is 1 times 2 is 2. 1 times 3 is 3. 2 minus 3 is minus 1. So yes, minus 1. Then here, 1 times 3 is 3. Then 2 times 1 is 2. 3 minus 2 is 1. Then if we come to this place, 1 times 3 is 3. Then minus 1 times 1 is 1. So 3 minus 1 is 2. Then if we come to this place, 1 times 2 is 2. Then 1 times 1 is 1. 2 minus 1 is also 1. Then if we come here, 1 times 6 is 6. And 3 times 1 is 3. 6 minus 3. Here is 3. Then 1 times 6 is 6. 1 times 1 is 1. 6 minus 1 is 5. Then in this place, 1 times 3 is 3. 1 times 1 is 1. 3 minus 1 is 2. So this is the matrix of minus. The next thing we are supposed to do is to find the matrix of cofactors. And remember what we said. We multiply that one by this signs. So plus minus plus. Minus plus minus. Then plus minus plus. So if we take minus 3. Minus 3 times 1 is minus 3. Then here minus 3 times minus 1 is 3. Then here minus 1 times 1 is minus 1. Then at this place, 1 times minus 1 is minus 1. Then 2 times 1 is 2. Then here 1 times minus 1 is minus 1. Then at this place, 3 times 1 is 3. Then here 5 times minus 1 is minus 5. Then 2 times 1 is 2. So this is the matrix of the cofactors. And then the last thing we do is to write the inverse. So B inverse, remember we said B inverse is equal to 1 over the determinant of B times the adjoint of B. So B inverse equal to, we got the determinant as minus 1. So 1 over minus 1 is the same as minus 1. So minus 1 then times the adjoint of B is to find the transpose of the cofactors. So take the first row and make it the first column. So minus 3, 3 and minus 1. Then take the second row, make it the second column. Minus 1, 2 and minus 1. Then take the third row, make it the third column. So here's 3, minus 5 and then 2. So let's simplify further. So minus B inverse is equal to, here if we multiply through by minus 1, here we come 3 and here we come 1 minus 3. And then here becomes minus 3 minus 2 and then 5. Here becomes 1 1 and minus 2. So this is B inverse.